Good evening, my YouTube viewers. It is Crystal here, and I'm just here because I want to give you another demonstration of the SVM classifier. What we want to do is we want to find out which classifier is better. Is it a made-from-scratch classifier, or is it sklearn's off-the-shelf classifier? I'm trying to figure out where I got the code from. I got the code from this GitHub account here where it says simplest SMO ever. And I found it on this website here. And from this guy, Vitaly Bogdanovich Timchivin from the National Academy of Science in Ukraine. So that was done 14 Feb 2021. And the question was, I'm looking for SVM code without using any library, raw SVM code for sentiment analysis. Can anyone help me? And so it was this guy, Vitaly Bogdanovich Timchivin, is the one that I looked on his site and got the answer. So you'll know where I got the code, because obviously I'm not a good enough programmer to be making all this code since I've only been working on data science for about 2 years now. So I've got a long way to go, you know. So the first thing we're going to do is we're going to look at the made from scratch SVM classifier. So we have class SVM. And then it says def in it, so that's your initializer. And it says you set up your, I think the default is linear. And the C is 10,000, max is iter is 100,000, degree equals 3, and gamma equals 1. So I think that's the default. And you can set it up for poly, RBF, and linear. And so self.c equals C, self.maxiter equals maxiter, and then you set up the function restrict to square. Then you set up another function, def fit. So if you've been working with machine learning, then you probably know what fit is, because you have to fit the training set into the training data into the model, so you probably know what fit is. And it says you set up your function, decision function, and then you set up your function of predict. So those are the functions in class SVM. So after we set up our class SVM and the functions, then what we want to do is we want to set up a program. And so we're going to import our libraries, and in this instance we imported NumPy as NP, and that's your numerical computation library. And then you're going to import pandas as PD, and so that's your data processing library. We're going to import matplotlib.pyplot as PLT, that's your graphics library. We're going to import Seaborn as SNS. That's another higher level graphics library that's written on the back of Matplotlib. And then what we're going to do is we're going to go into sklearn and we're going to load the breast cancer data set. So from sklearn.datasets, import load breast cancer. And then BC equals load breast cancer. X equals bc.data. Y equals bc.target. So we're going to convert this to a data frame. df equals pd dot data frame x. df target equals pd dot data frame y. And then df, and then we're going to normalize it. So df equals df minus df min over df max minus df min. So when we normalize it, what we do is we take all of the data values and we convert them to a value between 0 and 1. So now what we're going to do is we're going to define our train and test sets. So the train, we're going to use pandas to do that. So the train equals df.sample, frac equals 0.9, and random state equals 42. So the sample takes the data set and it shuffles it. And then the frac equals 0.9 means that you're going to get 0.9 of the entire data set. So you're not going to get the entire data set. And then the test equals df.drop train index. So the df is going to be shuffled, but what you do is, what the test set does is it drops the train index. So it drops all of the rows that are part of train. And then so we check the train and the test shape. So the train shape is 512 rows by 31 columns. And the test shape is 57 rows by 31 columns. And then so now what we do is we set up our X train, Y train, X test, Y test. So X train is all of the columns except for the last one, and Y train is the last column. X test is all of the columns except for the last one, and Y test is the last column. And then we do X train dot shape, Y train dot shape, X test dot shape, Y test dot shape. So on X train dot shape you've got 512 by 30, Y train dot shape you've got 512. X test dot shape you've got 57 by 30, and Y test dot shape you've got 57. And now what we're going to do is we're going to set up our model using the SVM classifier. So model equals SVM, kernel equals linear, max IDER equals 500, C equals 1, gamma equals 0.001. Model fit X train dot values, Y train dot values, Y pred equals model dot predict X test dot values, and then you've got your Y pred. We check the accuracy of that using a function that I sort of created the other day, and we got 98% accuracy. Now we're going to compare this to the sklearn's off-the-shelf SVM. So model equals svm.svc, kernel equals linear, max IDER equals 500, C equals 1, gamma equals 0.001, dot fit X train Y train, Y pred equals model dot predict X test dot values, and then you've got your Y pred. So, and now what we do is we check the accuracy, and we've got 98% accuracy as well. So in this particular instance, there's no difference between the made from scratch SVM classifier and the off-the-shelf SVM classifier. But what I will say is I had to experiment with the kernel. I had to experiment with the kernel and find the best kernel, which I found to be linear. And then I had to experiment with the C, the max IDER, and the gamma. So I've got a lot more I could do with it, because one thing that I should have done, or I could have done, was I could have inserted code to remove the redundant columns, which I'm going to go ahead and do that now. So, because the thing is if you have a lot of columns of data or a lot of features, then what that does is that generates noise. So if you're able to get rid of some of the redundant columns, then hopefully that will aid in your predictions. So when I finish this video, I'm going to go ahead and do that, try to delete some redundant columns and see if I can improve the accuracy. And another thing that I could have done was I could have done a heat map on it, which I think I'll go ahead and do a heat map as well, now that we're, since we're going to be working on this program. That's another thing that I can do. but I was in a hurry. I didn't want to spend too much time on it, so I did it really quickly, but I'm going to go through and do a few more bits and pieces to make it more understandable. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching this video. I look forward to doing more videos for you in the future.